This is problem 6 from the Chapter 2 closure packet. Write a rule for the given tile pattern. Then how many tiles will be in figure 58? So write a rule that also just means an equation in the form y equals mx plus b, because it's growing at a linear rate. It's growing at a constant rate every time. So let's figure out what that is and write an equation for that. So I'm going to count 1, 2, 3, 4, 5, 6. There's 6 in figure 1. Then there are 9 tiles in figure 2 if I count those up. And there's going to be 12 tiles in figure 3 if I count them up. So the change that's happening every time, the change in my y, or the change in the number of tiles, is it's adding 3 for every figure number. So that's going to be my slope. My slope is 3. It's adding 3 new ones each time, or the growth, if you like to think of it as that. Now I need to find the starting value, so I need to figure out how many are going to be in figure 0. How many would be over there? So I'm going to just go backwards 3. If I were to take off 3 tiles, there would be 3 left. So this is my starting value now. Okay. So my equation is going to be y equals 3x from my slope plus 3 of my starting value. So here's my equation. So that's the first part of the question. Write a rule for the given tile pattern. Now how many tiles will be in figure 58? So the figure number, if I were to make this into a table, the figure number would be the x, and the number of tiles would be the y. So when it wants to know figure number 58, that's talking about the x, when the x would be way over at 58, over here at 58. Okay? So I'm going to plug into my equation y equals 3 times 58 plus 3, because I'm replacing this. I want to know how many tiles, which is y. I don't want to know the opposite thing. Okay? So when I plug that in, I'm going to get y equals 174, then plus the 3, so I'll have 177 tiles in the 58th figure. Okay? So we had to write an equation first, and then plug in the figure 58 for x.